Hi there, Jim here. Today I've got a multimeter that we're going to put through its paces. We'll start with the unboxing and then we will run through a variety of tests to see how well it works. This multimeter, you can sort of see it's a fairly nondescript box, so it's a sort of unbranded box. As we'll see, it's branded to be a Proster multimeter. Proster is a brand name that essentially sources its components or its devices from a variety of OEMs, and they brand them. Um, I got this particular unit through the Amazon Vine program in order to perform review and evaluation, and that's what we're going to be doing. Before we really get into this, I'd just like to say if you find this video to be helpful, please give it a thumbs up, or better yet, subscribe to my channel. Questions and comments are always welcome, and I really appreciate the feedback because it helps me know where I can focus my efforts. So now without further ado, let's get into the box. So the box is, oh, maybe I opened the box already. Okay. So what do we have in here? We've got an instruction manual. It tells us it's a 9,999 count digital multimeter. It's got several languages in it, as is sort of typical for these. And so the first 16 pages are in English. We've got German, French, Spanish, and Italian through the remainder. So we'll have to see if we need to make use of any of that. Most multimeters and functions are pretty much the same. If you know how to use a multimeter, you probably won't need this. The box, there's a zippered case. The rest of the box is empty, so we can get rid of that. We'll open up the case. Okay, inside, upside down, of course. What do we have here? So there's the Proster T58B multimeter. It's sort of got a nice chunky feel to it. So it's not a slimline meter. I would say that's for sure. It's got some probes here, and we'll see what those probes do. This reminds me a lot of the Habotest multimeters. We'll have to see if there's any way to figure out if it's related to them or not. It's got a plasticky, rubbery sleeve here, and that looks like it would come off, although there's a groove around the edge that likes the groove. We don't need to take it off in order to put the batteries in. And it's got some slots here that'll hold the probes. We're maybe getting ahead of ourselves. Let's put that to the side for a second. So there's a bag here with a pair of probes. That could almost be silicone. Has a nice feel to it. It's yeah, very nice. And so the probes have these shrouds at the end that are easy to remove. So in high voltage scenarios where you're concerned about arcing or, touching something accidentally, those shrouds come in handy. Now the probes, these are fixed, so you're not going to be able to change the ends on these, but that's okay. And of course, these come out fairly easily, so the jacks there, easy to access. Okay, then there is in the package here a a pair of alligator clips. Okay, and these are intended to slide on the end of the probes. So if you pull that off, you've got that, and now you can, whoops, you have to pay attention. Oops, I pushed that out. So there's a little spot there. I guess it's a little harder to do than I thought. Okay, so that's designed to kind of get placed on the end of the probe, and then you've got an alligator clip instead of just the tip there. It kind of reminds me of the first multimeter I ever had that I got from Radio Shack that had a pair of probes like that, clip-on alligator clips like that. So this will probably be easier to put on the second time once the metal gets a little stretched to accommodate the probe. Okay, so a pair of alligator clips. I like that. It's a nice touch. And of course, what seems to be an obligatory part of almost every meter these days is a temperature probe. So I think including the temperature probe is a sign that manufacturers want to say, hey, now you can use your multimeter for HVAC, because you can test the temperature of the air coming out of the HVAC system. So these probes are pretty typical. They've got a little thermocouple on the end. Hopefully you can see that. And then they plug into the lines, and that there's a setting on the meter here somewhere for temperature. Oh yeah, here it is at the end, Celsius and Fahrenheit. The thermocouple generates a small voltage that can be measured and then converted to a temperature reading. So that's everything that's in the bag. Well, I shouldn't say that. There's a pair of batteries. Now I'm gonna put in a standard set of Kirkland Costco batteries. I'm not gonna use these. And of course, because they feel that if you have a multimeter, you probably have no tools, they've given us a screwdriver to use that we can use to get into the battery compartment here. I think I've got a screwdriver to use. So let's get the batteries in there and power it up. So we've got AAA's. We have a real screwdriver. And one of my must-haves for any unit is the brass threaded ring there, in order to make sure that we don't totally destroy the cover there. So the screw fits in there perfectly. We can see we've got a fused area here at the bottom, so the fuses are accessible without having to open up the entire unit. So that's a nice touch. And there's a couple of spare fuses in the case as well. So that's a nice touch. That's really appreciated, because quite often accessing the fuses is a huge pain, and then of course you never have a spare fuse of the kind you need. So that's quite lovely of the manufacturer to do that. So now let's get these in here. Okay, and we'll just give it a quick check to make sure. Yeah, comes on. Okay, it's happy. All right, and put that back, and we'll get the screw on there. Okay, and we're good to go. This unit reminds me quite heavily of Habotest unit that I have, because these sockets for the probes, they light up when you make a selection. So just for example, before we get into the testing, if I want to measure voltage, so I'm going to turn it to the voltage setting here. Now watch what happens to the sockets here when I do that. Okay, so you can see that these two sockets are flashing to tell me, hey, if you don't have a clue, this is where you should be plugging in the probes. And of course, common, we know common is where we should put our black probe, and the other ones are all colored red anyways, but that's where our red probe is going to go. And so now we're good to go, and we can measure voltage. Now, that's not the only thing we're going to do, but that's one of the things that we can do to start with. Okay, so let's turn that off again. Now, one of the things that I'm going to do, just as part of what I do in all of these reviews and evaluations, is I tend to compare the meter under test, or the device under test. I tend to compare it against my Fluke 117 here. Everybody in the world, I hope, by now probably knows the reputation of the Fluke devices. So they're generally considered to be one of the gold standards, if not the gold standard for multimeters. So I use that as a reference point to compare to what we're seeing. Now, this meter has a lot more features and functions than the Fluke does. Like you'll see, the Fluke doesn't have a temperature setting. They didn't go in for that. But for the most part, there's a lot of similarity between what they can do, and so certainly good enough for using as a reference. One of the things I should mention that I'm not going to get into a lot of detail on, there are a lot of settings here that are fairly common, and so so you'll see settings here like min max and peak and hold and things like that. So I'm assuming that more or less you understand how those sorts of things work. Let's get started. And the first thing that I'm going to do is I'm going to test DC volts. So we'll dial the unit to DC volts, and we can see right off the bat it's in DC volts here. It's showing DC there. The other thing, just to show this piece, if we press func, then it switches over to AC volts, and then that's visible down at the bottom here. Another thing that's interesting about this meter, before we go too far, is that it has a light function. And so if I press that once, now you don't kind of see anything there, but there's a light sensor somewhere here. There we go. And so you can kind of see that if the light sensor gets obscured, then the backlight comes on automatically. So that's kind of neat, because the backlight's not always on, but it is on if you're in a dark environment. So that's a pretty nice feature, I think. Anyways, let's get back to measuring DC voltage. We'll just go back into DC there. We'll also set the Fluke here for DC voltage. So let's see what we get off of this battery. Got our probes, got our battery. 1564. Let's try that with the Fluke. 1562. So that's, I think that's pretty good. That's pretty comparable. I'm happy with that. I don't think there's any level of inaccuracy to be concerned about. Either of them could be inaccurate. So that was DC voltage. Now let's try AC voltage. So what I usually do for AC voltage is I have a cord, and it's plugged in off to the side here. And so it's a device cord. And so I usually just do things that you tell your kids not to do. Let's get this into AC voltage here. Where are we? Func. So that's AC voltage. And we take the probes, Stick them in. Okay, so now you can see it's telling me I've got 121, almost 122 volts, 60 hertz. So it's nice that it has a multi-line display. It's also gone to a bit of an orangey red display. And so that's meant to tell me, hey, better be aware, that's a dangerous voltage level. Better be careful. Now, the one thing that was a little bit sort of surprising to me is the amount of time it took. So that's, okay, so you can see it took a bit of time to figure that it was AC volts and that it was dangerous. So meanwhile, if we do that with the Fluke, set the Fluke to AC volts. So the Fluke only has a single line display, so it can't show me the frequency at the same time. But of course we can plug in one side, and then let's watch how quickly the Fluke reacts. Okay, 121.4. So it's much faster to show me the voltage. It doesn't glow orange, but at the same time, it's quicker to show me that voltage. So now when it comes to the accuracy, it's really hard to tell with AC volts because mains jumps around a bit. Let's watch that one more time. There we go. Yeah, see, the voltage has probably dropped down. So I think in terms of AC volts, the accuracy is fine, but I'm a little disappointed with how long it takes in order to come up with the reading. So that's a little bit disappointing. All right. Next thing that we want to try out is resistance. And so to do that, I've got a breadboard circuit here that we're going to use for a couple of the other tests. So the resistor here, it's color coded. If you can read that, it's brown, green, brown. So technically that should measure out to something close to 150 ohms. So I'm going to get this back on the breadboard so it's not jumping around like mad. And we'll see what we can measure it at. So let's get the meter here into ohms. So that's this setting here. And it is set for ohms by default. The function key will cycle us through from ohms to diode check to continuity and back to ohms. Okay, so let's measure the resistance here on this resistor. 149.9, 149.8, 0.7. You can see a little bit of variance. So that's pretty close to 150 ohms. I think that's pretty good. Let's see what the Fluke has to say. We'll put it on and we'll measure it. 149.6. Now let's just look at the speed again here. 149.6. And this one, so for the accuracy, I think they're pretty good, but in terms of speed, pretty good. So let's do that one more time. $149.8. So pretty quick, but I think if you look at how this works with the Fluke, once again, it's faster. So accuracy is about the same, but the Fluke is just quite a bit faster. Now, let's move on to the next test, which is continuity. So continuity, I love this test because it's very simple. Diode check, continuity. And the reason I love this test is because essentially all you end up doing is tapping the probes together. And what you can see that's pretty fast. But a quick tap and a release, it doesn't notice. But so that's reasonably good. But I got to tell you that when it comes to continuity, I haven't seen anything perform as well as the Fluke. Okay? The Fluke, because it's just faster all around, it notices these really quick taps. Why is that important? You know, as opposed to just sort of an academic exercise, if you will, to see who the fastest gun in the West is. You know, if you're dealing with something that is intermittent, sometimes you're trying to troubleshoot a connectivity issue or a short circuit, and the short circuit is very intermittent, things are jostling around. You want to be able to catch that when it happens, because it's super frustrating to miss it. And so you want something that is just going to, you know, catch that continuity when it happens, as opposed to something like that. Right? So it's good, but not as fast as a Fluke. And I have to say that I've tested about a half dozen multimeters, and none of them have been as fast as the Fluke at detecting continuity. Okay, next thing that we want to go to is we're going to do a capacitance check. So we'll switch into capacitance. Okay, it's a dedicated mode. I'm not sure why it's marked in orange there. And the probes are still in the right spot for capacitance. I have a capacitor here. This one is listed, if you can see that. Not sure if we can focus in on that. It's 47 microfarads. So let's give that a go. And of course, it's an electrolytic, so it's polarized. So you have to make sure to get the right polarities. So I'm just going to, one probe there, one probe there. Okay, 48. It's probably pretty close. I wouldn't think that is off. 48.28. Now let's do that here with the Fluke. With the Fluke, it starts out in diode check, so I press that to get into capacitance. Let's make sure to get the polarity right. Okay, so 49.8 is what the Fluke is telling me. So that's very close. Once again, the Proster 48.3. So pretty close. Capacitance is a tricky thing to measure because you have to do a little bit of charging up of the device in order to measure the capacitance. Okay, so once again, pretty close. This is supposed to be 47 microfarads, so I would believe that. All right, now let's try diode check. So I've got a handy diode, and so if we hook this up in the right way, we will get the forward bias voltage of the diode. So negative, negative, positive. Whoops, am I in diode check? No, I'm not. I'm in resistance. Function, ohms, diode check. Okay, so now I'm in diode check mode. Okay, so about 200 millivolts, or 0.2 volts. Okay. Pretty quick. Let's try that with the Fluke. I have to put that into diode check. Okay. Once again, it beeps to tell you that you've done it properly. And almost 200 millivolts, so a little lower. Slight differences in accuracy. Now, just to show what happens, if you get the polarity wrong on the diode, it'll show 0, and it won't beep. So when you're trying to test a diode, right, getting it hooked up the right way, you get the forward bias voltage, but also beeps to tell you that it's working. So once again, if we go over to the Proster here, Hook it up. Okay, so works just fine. Shows us the forward bias voltage. It's pretty close, within a few thousandths of a volt compared to the Fluke, but no beep. All right, so that's diode check. Let's have a look at non-contact voltage settings. So I've got both of the units set up into non-contact mode. Now I've got the Fluke. The Fluke has a high setting and a low setting. The Proster only has one, so it doesn't have a range option on that. So when it is a non-contact, it shows EF, so saying that it's looking for an electrical field. I've got this cord, so this is plugged in, so it's electrified. And if I run this cord at the end there, you can see it picks it up. Okay, so it's got an indicator. On the other hand, the Fluke on this low setting, the Fluke is about the same. But the Fluke also has a high range. Now the high range can be somewhat maddening, but okay, the Fluke is much more sensitive to that. There's something close to the bench that's triggering it. But if I hold it up in the air here, you can see that even if I just get in proximity, it's going to sense that, put it back to low. Whereas with the Proster, it may sometimes trigger. There we go. Okay, so I'll let you kind of draw your own conclusion there. I mean, I think that the Fluke is far more sensitive, especially in this high range. So it senses things from a greater distance. All right, so that's non-contact voltage. And the last thing that I'm going to do is we're going to try out DC amps. This is a little bit of a new one for me to add into the mix for these videos. So I've got a little test circuit here, and I'll just bring that up here. So on this breadboard, you can see I've got my 150 ohm resistor. This breadboard power supply, when it's turned on, is going to generate 5 volts. And we're going to measure the current flowing through the circuit when we've got 5 volts, 5 volts with this 150 ohm resistor. And if you do the math, if you remember Ohm's law, we should get something around 33 milliamps, 0.03 amps, if that all works out right. And so just remember that it's actually 0.033 is what it technically computes out to. So something close to 30 milliamps is what we expect to have flowing through the circuit here. So I'm just going to lay that down. And I've turned the power on there, so you can see a little light has come on the breadboard. The breadboard power supply is supplying 5 volts there. If you want to check that, there we go. 0.498, so pretty close to 5 volts, okay? And we'll do it with the Fluke as well. 4.971. Okay, so pretty close. Like I said, no complaints about the voltage reading there. Now, when we switch over to current, okay, so we're going to switch this one over to current. We're going for milliamps. So you can see that this one is flashing now, so we've got to move this lead over. So the flashing of the sockets is fairly nice. I like that. Okay, and so the circuit is all hooked up, and so if I touch this point here to get my hands organized. So I touch this point here, and that point there. We see 31.892 milliamps. So that's pretty close to what we're expecting. The resistor is not dead on at 150 ohms. The voltage is not dead on at 5 volts. There we see 32.3. So pretty close to what we're expecting. Let's have a look with the Fluke. We'll dial it to, no, that's AC amps over there. And same thing, we've got to move the lead over here to measure amps. And touch those points. Whoa, look at that, dead on. 0.033 amps. So the Fluke does a fantastic job with that. Okay, 32 milliamps. So almost 33. Well, it's 33 if you round it off. So good accuracy on the amp measurement as well. I'm not going to really show AC amps because I think if you're really into measuring AC amps, well, I'd suggest you go get yourself a clamp meter. It's usually a more practical and pragmatic thing to do. We'll do a quick test here of the temperature. I'm just going to turn the Fluke off since it doesn't have anything there. So if we take these temperature, we'll disconnect these probes. We'll switch. Okay, so once again, it's these two that I'm going to plug into. And of course now we can see that we've got an internal temperature sensor showing 26, the external temperature sensor showing 27. I don't think it's 26 or 27 degrees Celsius here. It is a little warm. Now if I hold that with my fingers, you can see that's rising a little. You know, it's good for coarse temperature measurements. Like I said, if you were working on your air conditioning or something like that, it would be a good way to tell whether it's generating cool air, because you'd see some sort of a temperature drop from the probe as compared to the internal temperature. Just like when I held my fingers, right? The internal temperature is not changing. I'm not touching that internal sensor, but the external sensor is changing. So that, you know, it works. It does what it's supposed to, and it's handy to have. You know, it's interesting that it has ranges here as well for not just the milliamps, but for microamps as well. So, you know, quite a sensitive unit that it can go down into those sorts of very low ranges. So that's handy if you're doing a lot of sort of microelectronics and hobbyist kinds of things. So a very kind of flexible unit. Now, a couple of other things to point out just before we finish, and I do owe an explanation of what this peak setting does, so we'll come back to that. But there is a light that you can use, so if you're in a dark environment, hold that button down, there's a light that comes on. And I mean, it's not super bright, but if you were in a dark place, you can't see that, it might help. Might help illuminate a dark panel in a darkened room. This unit has an interesting feature, which is the peak feature here, which works for both AC voltage and AC current. So let's look at it for voltage. So we go into voltage. Now we're in DC volts. function, so we're in AC volts, and we press peak, it's turned on peak, and it says peak maximum. So let's connect this to the sort of supply. One probe in there. Okay, so you can see the peak maximum there is 167 volts. If we press peak again, the minimum is minus 165 volts. Okay, so in when we're not using this peak-to-peak setting, right, it's giving us a RMS value. So we'll turn that off. So if we turn that off and we look at the AC volts, right, that's giving us an RMS measurement, which is for a sine wave, a kind of an averaging, if you will, of the voltage level. So 120 volts. But you can see that the peak voltage, both the peak maximum and the peak minimum voltage, are quite a bit above that. So that's what peak does. Something that's kind of handy if you're measuring AC signals. So in summary, this is actually a pretty decent overall, a pretty decent multimeter. I've been pretty happy with the accuracy on all of the measurements. It would certainly do for a hobbyist. I don't think there'd be any complaints about it. I like all the features. It's got some novel things like the peak measurement, if you will. The speed of response on the continuity and the speed of doing the AC voltage measurement was maybe not the greatest. You know, if you're looking for something for work on AC, then maybe this is not the model that you would want to get. But you know, for most other purposes, I think this is a pretty decent multimeter, and it's got good accuracy. And I think for a hobbyist, do-it-yourselfer, really nice unit. Now, I just want to mention, since I like to kind of sleuth out where the origin is of these various units, this unit from Proster is very similar to a meter that I've had for quite a while, and I believe I've done a review on it. If I have, I'll put a link to it in the below. But the Havotest. So this is a meter I've had for quite a while. The Havotest HT118A. I really like this meter. Havotest is a Chinese manufacturer. They're an OEM of meters, and they have all kinds of different meters that they sell. And it's very similar in the sense that if I turn this on, you'll see that it's got lights on the sockets here. So the Havotest is the only other meter that I've seen or had experience with that has these lights. And of course, the design here, you know, of voltage and millivolts and how these things are organized, this is very, very similar between the Proster and the Havotest. And so I'm going to do a little bit of sleuthing, and I'll put some overlays for what I find in the video. But very similar, seems very similar model or lineage, if you will. Thanks for watching. If you've enjoyed this video, if you'd like to see other similar kinds of videos, please subscribe to my channel. Leave me a comment down below in the comments section. And until next time.